Well, we made it to Friday. This is Mrs. O'Donnell. And we made it through almost all of our probability unit. So we do have these 3 activities at the end. Some of you have probably already noticed that they're not graded. But I'd still I hope that you get into them and give them a try because they're pretty cool activities. And if you haven't already tried them, I would encourage you to stop watching this video at this point and to get into Delta Math and try these activities without any help because it's going to be a better learning exercise if you struggle through it. That being said, I make these videos to give you guys help so you're not stuck in the struggle, right? So that's what we're going to do today. Okay, so I'm going to hop over right now. So if you don't want my help or you want to try it on your own first, now's the time. Stop the video and go ahead and pop over to Delta Math. Otherwise, let's get going. So it looks like our first section that we're going to try is simulation of flipping pennies. Okay, so I know that one thing that happens a lot with students is you guys look at this stuff and visually there's just a lot going on the page. So first of all, the teacher options, I don't know if you guys can see that or not, but we can just hide that. Okay, then the next thing we should be looking at is what is happening on this graph. So we want to look at our intervals. It's telling us simulations that have been run, what is the mean, what is the standard deviation, and it looks like we're looking at coins, right? We're flipping a coin. So, 0 successes, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. So it looks like this is the probability that they're listing out on the bottom here on our axis, right? And hopefully that kind of makes sense. Like in theory, if you flip a coin, you've got a 50-50 chance or 50% chance of getting heads or tails, right? So the most coins should land on heads or tails, whatever. I'm not really sure what this one is exactly measuring, but anyway, so let's go ahead and flip the coin. We're not really given a lot of directions here. So let's see here. It's asking for the proportion of tails. So I'm going to go through and I'm going to count. And I know my probability is always my successes. So it would be the number of tails that I got divided by the number in my sample space, right? So my sample space would be, what would my sample space be? So I've got 1, 2, 3, 4, 5, 6 tails out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tries, 10 flips. And let's see what Delta Math says about that. We know we could reduce that as well, but let's try it and see. Does Delta Math, the proportion is correct, divide the number of tails by the total number of flips. Keep your answer as a decimal between 0 and 1. Okay, so we did divide the tails by the total number of flips, but I didn't write it as a decimal. Okay, so 6 out of 10 isn't going to work. I need the decimal equivalent, which is 0.6. All right, so Delta Math took that one. Now it looks like it's adding coins. Oh, it added a coin to the 0.6. Okay, we could see here. Submitting is not possible, just follow the directions. So we could try it again, right? I think you're supposed to try it like 5 times, right? So that's what I asked you guys for, is like 5. So proportion of tails, so let's see here. We got 1, 2, 3, 4, 5, 6 tails, and that's out of 10 again. What? So 0.6 again. All right, let's flip the coins one more time. All right, so now I got 6 tails again. Oh, let's do a new problem. Let's try that. Okay, close out the teacher option. All right, so number of flips, go ahead and flip the coins. Now our probability is distributed a little differently. Okay, so they want to know the proportion of tails. 1, 2, 3, 4, 5, 6. Oh my gosh, what is happening that it's always 6 out of 10? Is it going to give it a 6 out of 10 again? Ah, finally, something different. All right, proportion of tails. So now we've got 4 tails out of 10 flips, which we know 4 out of 10 is 0.4. Let's see if Delta Math likes it. They did, huzzah. Okay, and then we could even go to like a new problem. Well, now I'm just poking around. I'm not really sure what all the clear data is. Maybe that's what I'm doing wrong. Doop, doop, doop. We learn from mistakes, right? Clear all simulations, clear data. Generate 5 simulations for 10 flips. Let's see. Generate 20 simulations for 10 flips. Let's see what happens. All right, this is a different problem. Clear all data. Let's just do a new problem. Oh. Okay. Well, now we're not even getting. So, generate sample simulations. So generate 50 simulations for 10 flips. So we're going to generate it. Okay, so then this is the curve that they're giving us. Then we go ahead and flip coins. Maybe I had done this already, so I had some data stored. Anyways, so I just picked, right? I just picked simulations, and what this did is it went ahead and it did 50 flips. Or 500 flips. 500 flips? 500. It did 50 10 flips, so 500 flips. Because each coin in our graph represents 10 flips. The probability in 10 flips. So, is what it looks like. So then let's see here. I've got 5 flipped over that are heads, 5 flipped over that are tails. So that means that my proportions of tails would be 0.5. Here we go. What if we try, I have a feeling that's going to be real cray. Oh man, look at all those flips. Look at all those flips. Go, 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 go. Oh, it's still going. It's still going. Go, 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 go. All the pennies. Still going. Still going. Okay, finally done. Okay, so we flipped 230 heads, 270 tails. So our proportion of tails would be whatever 270 divided by 500 is. 270 out of 500, it's a little more than half, 0.54. And one little penny goes on 0.54. Okay, so this was a really interesting experiment, right? I just went to the biggest number that I could generate, that the program would let me generate. And we did all of those flips, right? And it gave me one little data point in my experiment. And so this is really good for learning like what kind of things you need to make a valid experiment. Like one little data point doesn't really tell us much about what's happening with the coin flip, right? Like we would need a lot more information to visually see it and make better judgment calls. Okay, I feel like we've got the flipping pennies activity down pat. Let's look at the rolling dice activity. Okay, so generate sample simulations. So let's see here. What if I generated 50 for 10 rolls? So we'll see what that does. Okay, so it added some more data points. So now I'm going to go ahead and roll my dice. So I roll my dice, and I've got 3 1s, 4 2s, 1 3, 0 4s, 1 5, 1 6, and I rolled 10 dice. So they want to know what are the proportion of 6s. So I would have 1 out of 6. 1 out of 6. It wants it as a decimal again. All right. So 1 divided by 6, that gives me the decimal. I'm guessing they want to the hundredths, although I clicked too fast to be able to read that. So keep your answer as a decimal between 0 and 1. There's 1/6 out of 10 rolls. Oh, I see what I'm doing wrong. 1 out of 10 is 0.1. Oh my gosh. There we go. So now it should be adding a coin. And we see it's telling us our mean and our standard deviation of the actual data set, right? So we know, like in theory, if you're looking at how often do you think you'll roll a 6, right? Theoretical probability, we would roll a 6 1 out of every 6 rolls, right? But what we see actually happening is very different than the theoretical probability. It's not necessarily 1 out of every 6 rolls. Okay. Let's see here. We'll see what happens if we make it a little bigger. Let's do like 50 rolls. Roll the dice. We changed it. I have to probably generate more rolls. Let's see here. Okay, now my rolls are generated. Now we'll roll the dice. Okay. So, proportion of 6s. So let's see here. There's 7 6s out of 50 rolls. Oh my gosh. 7 out of 50. That gives me a 14% chance. Okay. That's not too far off, right? If our probability, our theoretical probability was 16%, being at 14%, that's pretty good. Okay, cool. So we're learning lots. I have 3 minutes left. Simulation of sample means. Okay, so let's check this out. Sample means. Data must be cleared at the end of each session. Okay, great. Generate sample simulations. We'll do 50 again because that seemed to work pretty well. Generate. It looks like we've got them. Number of samples. Hide scores. Shuffle. Number of samples. And this is where skipping directions gets you in trouble. Fixed data set. The data set. Okay, so we're not generating our data set. The data set is normally distributed with a mean of 75 and a standard deviation of 8. The only thing that will differ is the different students will sample different values by clicking randomly. What? Okay, so this one's kind of weird. And oh, I see. It's for a survey. That's what we're doing. So all of these different question marks are like the people that you're surveying. So you've now completed the surveying and sample, find the average and round to the nearest whole number. Okay, so this is as if like you went to the store, which you're not allowed to do right now, but whatever. You went to the store, you asked 5 people, whatever the survey question is, and these were your results. So now they're just asking you to find the mean. So finding the mean, let's see here. 83 plus 71 plus 99 plus 76 plus 70 divide by 5. So 399 divided by 5 gives me 79.8. Oh, to the nearest whole number means 80. And they liked it. Huzzah! All right. So let's see here. All right. So then you can go ahead. You could try again by, you click try again, maybe shuffle, hide the scores. Oops. write the scores, and then pick your sample of 5